All right, boys and girls, we're moving on to example 2. And they want you to simplify sine squared of x times secant of x minus secant of x. So whenever they ask you to simplify, we're not solving for anything. You just simplify as much as you can. And you know you're done when you're basically when you don't know what to do, and you'll know because you're either going to go back and forth, and you'll know when to stop. Okay, so for this one, I'm going to do 2 examples, and I am going to be avoiding all the checkpoints because I figured between the examples in the book and the checkpoint, those are extra problems for you guys to do. Okay, so when I look at this, sine squared of x times sine squared of x times secant of x minus secant of x. I consider this a binomial because it's separated by a minus. So right off the bat, I think I can factor out a secant of x. Okay. Now, to simplify, you are going to be using the identities again on page 350, or if you decided to go ahead and rewrite them again on an index card. Okay, so what I'm going to do is I notice in this term, and I'm going to consider this one term, we have a secant of x, and in this term over here we also have a secant of x. So I'm basically going to factor it out. So I'm left with sine squared of x minus 1. Okay, and then and then look at your identities, and it's similar, not exactly, but it's similar to one of the Pythagorean identities, and that would be probably the first one, because the first one uses sine squared. It's the one that says sine squared of x plus cosine squared of x equals to 1. So I'm going to show you on this side. Okay, so the original identity is sine squared of x plus cosine squared of x equals to 1. Now, if you're wondering how can I get this to make it look like this, so if I subtract sine squared of x, I'm going to be left with cosine squared of x equals 1 minus sine squared of x, which is sort of similar, except they have it flipped. So look at what happens when I flip these. Then I end up with negative sine squared of x plus 1. Okay, but then this is giving me the opposite. Notice that sine is a negative and the 1 is a negative. So the way that I could do that is, is if I factor out a negative. So if I factor out a negative, then I'm left with sine squared of x minus 1. But what that means is the negative goes here. Okay, it's kind of like dividing by negative. So now this is cosine squared of x. Okay, so basically what I could do is I can now simplify this to negative cosine squared of x. So this is now secant of x times negative cosine squared of x. Okay, so now I'm thinking, what can I do with the secant and what can I do with the squared of x? So we know that secant is the reciprocal of 1 over cosine, which is really nice because here we have a cosine. So if I rewrite this, this would be 1 over cosine of x, and this is negative cosine of squared of x. Okay, and it's the same as if I were to do this, just multiply it. Negative cosine of squared of x over cosine of x. And then what happens is there's 2 cosines up here because it's squared, and then there's 1 here. So I can factor 1 in each. And so when I do that, what's left is negative cosine of x. And that's it. This is what I managed to simplify. So this now becomes that. Okay. And it's all using identities. Okay. So this is what it looks like. So let me see if I can zoom out a bit. Okay. Okay. And this is kind of side work just to show you this. Okay. Just to illustrate that. I really don't need that, but this all simplifies to just this, and that's it. Can't go any further. Okay? All right. I don't think one is enough for this one, so I'm going to go ahead and do another one for you guys, okay? Okay, the one that I'm going to do is number 41 in the homework. So here what I'm given, again, I have to simplify, okay? What I'm given is sine pi over 2 minus x times cosecant of x, okay? So let's look at the identities. Okay, so for this one, again, you want to look at either your index card or 350. So I would use one of the co-function identities, and the one that I'm looking at is the one that says sine of pi over 2 minus x is the same as cosine of x, okay? So this is automatically this, okay? It's one of the identities, and you can look at that. And then I have cosine and cosecant. So if I bring down the cosecant, okay, just bring it down. I'm thinking, what can I do with this? But cosecant is actually the reciprocal of sine over u. So, I'm sorry, sine of x. So I can rewrite this as 1 over sine of x and just bring this down, and this is cosine of x, or the same as cosine of x over sine of x, because I'm just multiplying it. And then boys and girls, cosine over sine is the same as cotangent of x. Okay. And that's it. Can't do nothing here. Okay. So again, this is an identity, which gives you cosecant. I just brought this down, but cosecant is 1 over sine of x, and that's an identity. And then multiplying this, I got cosine of x over sine of x, which is the same as cotangent of x. And this is simplified to that. Okay? And that's it. Okay, so I did 2 examples. I think that's probably enough for you to do some. And again, you can always refer to example 2 in the book and the checkpoint. Okay?